So we worked several frame problems that I think illustrated the process of working frames. And I can't overemphasize enough how critical the free body diagrams are. You must draw free body diagrams and then take frames apart to find free body diagrams. One of the things I didn't talk about is, so what does an exam look like? So an exam can't ask you for every reaction on this frame. So there's 9 different reactions on this frame. And they're probably not going to ask you for the support reactions. But what they might ask you for a horizontal reaction at D or a horizontal reaction at B. That would be a good exam problem. And so if they ask you for a horizontal reaction at D or B, so you would draw the free body diagram. So this is a horizontal reaction at D or B. So you just draw a free body diagram of the member that they're asking you about. And so you just take that member, draw him, and he's 1.5 and 1.5. You know this is 300 right here, 300. You've got a BX and a BY. And then you have a DX and a DX and a DY. So that's your free body diagram in this member. And so the problem might say, find the horizontal reaction at D or B. So you split this guy out. And again, you could draw this guy or you could draw this guy. But it's easier to just deal with him. So once you draw him, if you know this is 300, I can sum moments about dx. I can sum moments about d. And so if you sum moments about d is equal to 0, and we take clockwise to be positive, I have 300 times 3, so positive 300 times 3 minus bx times 1.5 equal to 0. And so bx is equal to 900 divided by 1.5. So bx is equal to 600 newtons, as drawn this way. And then once you find bx, you can sum forces in the x direction, and dx is equal to 300 the other way. That would be a fair exam question, asking you about one member of that frame. And you have to know that I can take this guy off of the frame, draw a free body diagram of just this guy, and deal with that free body and solve the problem. That would be a perfect exam question, one-step question. Another perfect question is just off the same frame. They might ask you for a vertical reaction on B. Like B, for example, pin. And you say, okay, I'm going to draw the horizontal here, ABC. And this is 2 and 2. You say, well, I think there's a 600 here. I'll draw them on this guy. There's a 600. There's a CX and a CY. I won't draw the arrows yet. There's a roller here at A. So there's an AX. But they might have asked me, they're asking me for a vertical guy. Well, because it's a roller, there's no AY. So AY is 0. And this is B, Y, and BX. Well, actually, if I already drew this free body diagram, I have to draw him in the opposite direction. This is BX to the left. And this is C. So this is CX and CY. But if all they asked you for is BY, you just take the member, cut him off, draw his free body diagram. At the roller, there's just a horizontal. If you said take a moment about C, because AY is 0 and there's no other force here, BY is 0. And then once you get BY is equal 0, then you know CY is 0. And so that's a legitimate test question. Taking a complex frame, but taking a piece of the frame, draw a free body diagram of it, and solve it. Classic exam question for a frame. So again, these examples I worked had you find 9 unknowns of all these different pin reactions, but on an exam, it's typically a single piece of a frame. And just draw the free body diagram of that single piece, draw the reactions, solve for what they're looking for. It's usually not super hard. They're just saying, hey, do you know how to take a frame apart? Do you know how to draw a free body diagram? And as long as you're able to do that, isolate a piece out of a frame, then it's a solvable problem.